This is part one of the junior cert sample paper, which you guys had for Christmas. You're dealing with a fraction in part one of question one. Write the numbers 3, 9, and 25 into the three empty boxes to make the mathematical statement true. So it has to be over 25. 24 over 25 is less than 1. So this 25 can't go on top, it would have to go on the bottom. So that's the only option available there. Now we're left with a 3 and a 9. So if we think about it, if we put the 9 in here, that's going to be greater than 1. So that can't happen either. So by a process of elimination, this has to be true. And we can double check it by converting 3 over 5 into over 25. You'd multiply them both by 5. 15 over 25 plus 9 over 25 is 24 over 25. So take your time to verify them, even if you're not asked. Then we have to write the numbers into the empty boxes so that the difference is as large as possible. So that would be the biggest number, take away the smallest number. So the biggest number is 25 over the smallest number. That will give me the biggest fraction. And what's left is a 5 and 9. So I'd have to take away the smallest bit of that, which would be 5 over 9. We're not asked to work it out or anything like that, so we can leave it like this. Now we're told a positive whole number has exactly 4 factors. A little bit tricky this one, but if one of the factors is 9, we know that we'd always start with a 1. So there's a 1 is a factor. If a 9 is a factor, it means that 3 has to divide into the number, because every number that has 9 as a factor, 9, 18, 27, 36 and so on, 3 divides into them all. So 3 has to be a factor, and 3 times 9 be 27. I think we have a number here with just 4 factors, just with a little bit of process of elimination and thought gone into it. 27 is the number. You can just see there's only 4 factors of 27. The only way to work this out is just with a little bit of knowledge of factors. Question 2 starts nice and easy. Millie needs 4 eggs to make each cake, and she's 28 eggs. How many cakes can she make? Now, you could just write 7 here, but show your work. 28 divided by 4 is equal to 7. That's where you're getting it from. Millie makes a filling for her cake using only butter and sugar in the ratio 5 to 7. And one day, Millie makes 2.4 kilos of filling. So a ratio question, 5 plus 7. There's 12 parts to the mix. If she makes 2.4 kilos, we'll convert that to grams, because we're seeing here grams, 2,400 grams divided by 12 gives 1 part, 200 grams. That's 1 part. And if we want 5 part and 7 parts, we multiply this by 5 and 7, 200 by 5 and 200 by 7 should add up to the 2,400 grams. That's 1,000. And this is 1400. You can see they do add up. And this is the one we're looking for. Grams of sugar is the second one, the 7. So 1,400 grams of sugar and 1,000 grams of butter in this mix. Now she's buying the flour at the local shop, and there's 2 special offers. Which one is the best? She wants 6 kilos of flour. So on offer A, 1 kilo bags, so she's going to need 6 of them. $3.50 each. But if she buys 3, she only pays for 2. So she's going to need 6 of them. So she's paying for 2 twice. So she has $3.50 for 1 kilo. If she buys 2 of them, it will be €7. And then she'll get the third one for free. So she multiply this by 2. Offer A, €14 for 6 kilos. And offer B, 1.5 kilos. So 1.5 by 4 is 6. So she's going to need 4 bags. And there are 5 each. €5 by 4 is 20. But she gets a discount of 20%, so we can take the 20% off. So we can either multiply it by 80%, because that's how much we'll pay, which would be €16. Or we can take the 20 and multiply it by 20%. To get €4, which we take away from the 20 to get 16. And you can see here, offer A is better value. Now Millie wants to sell each cake for $7.50. This gives her a profit of 20%, so just 750. If it gives her a profit of 20% is equal to 120%. So to get 1%, we divide 750 by 120. And to get what she costs her, we multiply by 100 to get 100%. And this gives €6.25. And now a compound interest question. She's 3,000 in the account. The interest rate is 2.5%. 0.02 will be 2%, so 0.025. But we do it a slightly different way than this. We add the interest rate onto 1 and bring it to the power of whatever the years are. And we'd multiply this by the investment of 3,000. Nice quick way to do it. This gives 3,311 and it's money, so 2 decimals 44 cents for part E. In question 3 we have this diagram below showing the percentage of total sleep that men and women spend in deep sleep. We have their ages on the bottom, between 10 and 70, and along the side we have the percentage of total sleep spent in deep sleep. We can see here already from the diagram that there's 2 points of intersection here. It looks like this one, and then the red line is below until here. The red line is women, so women sleep less in deep sleep than men. They have 18%. They're the same at this point, this 18, when they are 10 years old, and then when they're 50, the percentage looks like it's about here on the graph. It looks like about 12, 13 and a half possibly. So let's see the questions that follow this. Use the diagram to estimate the percentage of total sleep Gina spends in deep sleep when she's 20 years old. Just go up from 20. And you can see it's directly across from 16, so 16% here. Gina sleeps an average of 8 hours in each night. Work out how many hours she spends in deep sleep on average each week. So this is 7 nights, so we need to get 16% of 8 hours, and we need to multiply that by 7 to find out how many hours a week she spends in deep sleep. That is equal to 8.96 hours. Normally this question would ask for it maybe to the closest minute, so if you want to convert this to minutes, you just take your 0.96, multiply it by 60, and you'll get 57.6 minutes, which we'll round to 58 minutes to get 8 hours, 58 minutes for Gina in deep sleep on average per week. Then we're looking at this inequality here. Show the range. So we know we have 2 values in here, 2 numbers. It's range for which women spend a lower percentage of their sleep in deep sleep than men do. And we looked at this at the start. Let's have a look here at women. When are they spending time below the men? It was between this age here, 10 and 50. So that's our inequality between 10 and 50. Straightforward enough. Part D is scientific notation, no connection to the question really. 6 billion in scientific notation, so it's going to be 6.0. Just let's see how many zeros we have. We're told 1,000 million, so a million is 6 zeros. So we want another 1,000. We have another 3, so that's the number 6 billion. So if I put the decimal point in here, I've moved it 369 places, so 6.0 by 10 to the power of 9, or just 6 by 10 to the power of 9. This number A has to be between 1 and 10. This inequality is telling you that. And now we're given a linear. I told this is a linear model to estimate percentage of total deep sleep that men spend in deep sleep between 42 and 66. Some of the results are shown here. Complete the table below so that the percentages follow a linear pattern, so just underline percentage. So this jump from here to here has to be the same as the jump from here to here, and so on. The differences will be the same if it's linear. So we just have to look. The difference between 15 and 13.6 is 1.4. 15 minus 13.6 is equal to 1.4. If we divide that by 2, we get 0.7. So that will be 14.3, and this one will be 12.9. And the last part of this question, it says, using the values in the table above, Philippe writes the percentage of sleep spent in deep sleep as a function of age. There's a lot of information here, between 40 and 60. And then the graph of this function is a line with a slope of minus 0.14. And we're asked to explain what this minus 0.14 means in the context of this question. Let's have a look here between 40 and 60. And he's talking about men here, Philippe, between 40 and 60. You can see it does look like a straight line here, even on the graph. And we have a slope of minus 0.14 between this point and this point. So let's just have a look at what this means. So we take this value here, looks like approximately 15, say. This value here as approximately 12. So it looks like from 15 to 12, that's a loss of 3%. Now what is a loss? 3% of what? Total sleep spent in deep sleep over how many years? Between 40 and 60. So if we divide 3 by 20, we get 0.15, which is approximately the minus 0.14. Was it 0.14? The minus 0.14. So it's the percentage of time spent in deep sleep declining over time, or you could say between the ages of 40 and 60, 0.14% per year, 0.14% per year. Or when we get to leaving cert, we could look maybe at the rate of change, something along these lines we'll see going forward.